New York City's LaGuardia Airport, March the 22nd, 1992. A commuter plane with 51 people on board tries to lift off the runway.
Rotate.
But the pilots can't get it to climb.
They knew they were in trouble, but they were fighting all the way to the end.
US Air Flight 405 plunges into the icy waters of Flushing Bay. 27 people die. For US investigators, it's an open and shut case.
This accident was not a huge surprise to us.
But Canadian investigators are stunned. They know the New York accident should never have happened.
My reaction when I heard about it was, my God, it's Dryden all over again.
3 years earlier, an exhaustive investigation into a crash at a remote northern airport had identified a killer and spelled out ways to keep it from striking again.
Certainly, if they had followed the recommendations in my report, the F-28 crash at LaGuardia could have been averted.
The LaGuardia accident makes one thing clear. The right people never got the warning. March the 10th, 1989. It's 11:39 a.m. at Dryden, Ontario's airport. Light snow falls as Air Ontario Flight 1363 stops in the remote northern community on its way from Thunder Bay to Winnipeg. The passengers stay on board while the plane is refueled. For flight attendant Sonia Hartwig and the crew aboard the Fokker F-28, it's been a frustrating day of delays.
Big, fluffy, white snowflakes at this time were falling gently to the ground, and it was very, very gray. And I thought, I guess this means we're going to be delayed again.
I can't see us making it to Winnipeg on time.
It's Friday, the beginning of March break. Already an hour behind schedule, another delay could jeopardize the vacation plans of many of the 69 passengers and crew.
There was a lot of families traveling on board with plans. Most of them were going skiing, and so they were very concerned about meeting their connections in Winnipeg.
Kenora Dryden, it's Ontario 363.
Ontario 363, Kenora. We've got quite a...
As First Officer Keith Mills checks on weather conditions, Captain George Morwood returns from making a phone call inside the airport.
It's getting worse. What's the latest?
And it won't clear till late afternoon.
Check that. Quite heavy snow. Looks like it's going to be a bad one. It's still within our takeoff limits.
Well, that's good. We got a lot of people who want to make their connectors. Let's hope it holds.
Temperatures hover around freezing. Visibility is decreasing. If the flight doesn't leave soon, it could be grounded indefinitely.
Dryden is a very small city. It's a very remote part of Ontario.
With a population of about 6,500, the isolated community lies halfway between Thunder Bay and Winnipeg. Harsh Canadian winters with bitter cold reaching minus 35 degrees Celsius are the norm here. It's not the place to be stranded in the middle of a snowstorm. Royal Canadian Mounted Police Officer Don Crawshaw and his partner are escorting a prisoner to Winnipeg.
When we did a criminal check on the prisoner before we left, he came up as a violent person. So two of us have to go with him. He was wanted in Banff on a fraud charge, and that's what he was being brought back to Alberta for.
Okay, no smoking and seatbelts.
On.
Instruments.
Sinks. Cross-check.
Captain Morwood uses the power of engine number 2, already running, to fire engine number 1. Morwood and Mills are both highly experienced pilots. However, they've each flown fewer than 100 hours in the Fokker F-28. The multi-million-dollar aircraft is the first Air Ontario jet to serve the remote Northern Ontario region. 24 minutes after landing in Dryden, Flight 1363 is ready to leave.
Inform Kenora we're rolling.
We're fired up, taxiing for departure, requesting airways to Winnipeg.
Hang on a sec, guys. Is there a chance that plane can hold? We're having some bad weather up here.
An approaching aircraft's urgent request to land
Unbelievable.
gives Captain Morwood little choice. He delays takeoff.
Okay, 363's holding short of the active.
We are going to be a few moments until a small plane lands safely. We're sorry, folks. This just isn't our day.
In the 2 years that I had flown with Air Ontario, I'd never come across anything like this before.
The Cessna 150 lands safely, clearing the runway for Flight 1363's departure.
Tell them we're going immediately.
Kenora, Ontario, we're taxiing out at this time, 363 Dryden.
Finally, an hour behind schedule, the plane taxis to runway 29.
As we're going down the runway to position for takeoff, a blanket of snow was falling and I couldn't see the tree line anymore. It was like looking through a sheer.
Folks, we're sorry for the delay. Flight attendants, please be seated for takeoff.
At 12:09 p.m., Flight 1363 is ready for takeoff.
Advise Kenora, we're ready to proceed.
And Kenora, Dryden, Ontario, 363 is about to roll 29 at Dryden.
Ontario 363, Kenora, roger.
Captain Morwood performs a brief engine run-up, heating the engines to rid them of any accumulated snow and ice. Then he begins his roll down the runway.
When we're taking off, I'm usually very quiet and focused, meticulously going through a checklist in my own mind. What would I do in the case of an emergency?
E1,
The F-28 reaches its takeoff speed,
rotate.
80 knots.
Our takeoff was very slow and sluggish, like a slow, sluggish person running up a hill.
Clearly there's something wrong. The F-28 struggles to get airborne.
We cleared the trees. The plane started shaking.
I thought, oh my God, we're going to crash.
That's when all hell broke loose. If you can equate to being in a Mixmaster, that's what the plane felt like at the time.
There's this dip to the left and then dip to the right. The pilot's trying to get this plane up.
Then all of a sudden there was a power burst. The plane seemed to stabilize itself.
You could feel that the pilot's trying to get control of it.
But a few seconds later, it became a Mixmaster again.
I yelled out, emergency, grab your ankles, get your heads down.
Grab your ankles, put your heads down!
And I kept yelling that, and then I assumed my brace position. You could hear people screaming and yelling. There's loud, horrible sounds. We are clearly crashing.
The pilots are helpless. 49 seconds after lifting off, Air Ontario Flight 1363 crash lands in the bush, 950 meters west of runway 29.
There was carnage of the aircraft all over the place. I didn't know where I was. And at that point I thought, oh my gosh, I'm alive. I'm still alive, that this is all happening so quickly.
When we crashed, we came down on an angle. It ripped the right side of the plane open, and that's how we got out, or else we probably would have never gotten out. Now, the prisoner was still in handcuffs, so I reached over and I took the cuffs off of him there, but he never left me. And then we exited the aircraft.
There's fire all around, there's explosions. I'm thinking, oh my God, we're full of fuel.
Guys, come this way.
And I started yelling, come this way, for people to follow my voice.
Come this way. Come on. We're gonna go
Passengers
this way.
scramble for safety before the fire spreads. 45 people survived the accident, but 24 people do not, including Captain Morwood and First Officer Mills. Emergency crews rush to the crash site deep in the woods. The injured are taken to hospital in Dryden.
I was very concerned because I kept looking at the wing all the time. I thought it was a lot of snow.
Well, I didn't notice anything wrong going down the runway. Like I said, it was just when we started hitting the trees, I knew there was something wrong.
Within 24 hours, a team of investigators from the Canadian Aviation Safety Board arrives at the scene.
You're going there, hopefully with the idea that you can find out what happened, why it happened, and how do you prevent it from happening in the future. We walked the entire path of the airplane to the threshold of the runway, and then we walked the flight path of the airplane right to the crash site. That was the first thing that I did. I wanted to document what I was seeing by photographing. When you walk in on an accident site like that, there are two things that overwhelm you. The smell of aviation jet fuel and the smell of death.
The trees just past the end of runway 29 give investigator David Rohr and his team vital clues about the F-28's failed flight.
What happened was the airplane went off the end of the runway in what we would call ground effect and just stayed at that height, simply clipping the tops of the trees.
Look at how these treetops have been clipped off.
It didn't ever fly. You've got 24 people that died. You've got 2 pilots that died and a flight attendant that died. And they died, for the most part, trying to do their job. So you really want to do them justice, but you also have to be fair. And if there were mistakes made, mistakes have to be fixed.
From the rear of the fuselage, investigators recover the F-28's 2 black boxes, the flight data recorder and the cockpit voice recorder. The devices are designed to withstand temperatures of 1100 degrees Celsius for up to 30 minutes. Investigators are frustrated to learn that the mylar tape from the recorders has suffered extreme heat damage. It's estimated the black boxes were scorched by an 1100-degree inferno for at least 90 minutes, far beyond their limit. The data is unrecoverable.
That was a big blow to us because now you have to try and gather information and try and establish that it's factual by independent routes.
We were just about to leave Thunder Bay and they gave us 10 new passengers.
Investigators must now rely heavily on eyewitness reports to reconstruct the events leading up to the doomed takeoff. They learned that the F-28 began its day in Winnipeg and was scheduled to fly a return route to Thunder Bay and back with a stopover in Dryden. But in Thunder Bay, plans changed. The cancellation of another flight forced the crew to pick up 10 additional passengers.
And when they did their calculations, they realized that we were overloaded and something had to come off.
All right, let's offload some fuel then.
They ended up removing fuel in order to be within the proper weight.
Dispatch, Ontario 363.
So the flight was delayed an hour.
The extra weight of the new passengers left the crew no choice. They had to unload fuel to lighten their load. That meant when they arrived in Dryden, They needed to pump in more than the usual amount of fuel for the final leg back to Winnipeg. Roa wonders if the change in plans somehow led to a miscalculation of the weight and balance. Was the F-28 too heavy for takeoff? He then uncovers a puzzling detail. The plane's weight and balance form for the takeoff from Dryden was never collected as required. It burned in the fire. Roa is forced to use Air Ontario's standard averages to calculate passenger and baggage weights. The data, combined with the airport's fuel records, allows him to estimate the plane's gross takeoff weight.
We knew how many people we had on board. We knew how many bags we had on the airplane. And we knew what our fuel load was.
He estimates the F-28 weighed between 62,000 and 64,000 pounds.
And the airplane's max takeoff weight was 65,000 pounds. And so we came to the conclusion that the airplane was not overweight.
The cause of the crash remains a mystery. 18 days into the investigation, the Canadian government appoints Justice Virgil Moshansky to lead a more wide-ranging inquiry into all aspects of the aviation system that might have contributed to the Air Ontario tragedy.
The government was looking for an experienced trial judge, and preferably one who had an aviation background.
Moshansky is an experienced pilot with 13 years on the bench. He will work closely with crash investigator David Roa and aviation consultant Frank Black. The new team's first step, assessing the plane's technical systems.
The electrical system, the hydraulic system, the fuel system, all of these systems are looked at both in terms of what is their history leading up to the accident and what remnants are remaining at the crash site that can be examined.
Clues to a possible system failure arise when Sonia Hartwig recalls a troubling event aboard the same plane just days before the fatal crash.
I think it was Monday or Tuesday. When we took off, there was this smoke that filled the aircraft, and there was this horrible smell. I thought, oh my God, we have a fire in the lab.
But there was no fire in the lavatory or anywhere else in the cabin.
They told us that apparently it had something to do with oil sitting in the APU system. So every takeoff that day, this would happen.
The auxiliary power unit is a generator that provides the power needed to start the engines. Did burning oil in the APU somehow cause a fire and ultimately doom Flight 1363? Roa searches the week's journey log for any mention of the auxiliary power unit. He makes a surprising discovery. The APU wasn't working on the day of the crash. It couldn't possibly have caused the fire. But the inoperative power unit may still have played a role in the tragedy. Investigators learned that it forced the crew to make a risky decision in Dryden.
We're onto the connectors. Let's hope it holds.
Normally, the captain would rely on the APU to restart his engines after shutting them both down for refueling.
But if he couldn't use his APU, he couldn't shut his engines down.
That meant Flight 1363 had to be refueled with one engine still running.
Captain Morwood is in a situation where he's got a hot refuel with passengers on board the aircraft. He's got to keep an engine running to refuel the airplane.
Hot refueling isn't against regulations, but the risk of a fuel spill makes it potentially dangerous. In Toronto in 1973, a maintenance person was killed when an Air Canada DC-8 jet was consumed by fire during refueling.
Hot refueling is not a normal practice.
Could the hot refueling have caused some kind of damage to the engines? The Dryden airport manager, a former military pilot, suspects there was trouble with the plane's engines. He tells Roa he saw the takeoff from his office and heard a sharp, explosive noise just as it disappeared from view. To him, it signified a flameout or engine failure.
I thought, this is going to be a high-profile and potentially controversial investigation, and the only way to ensure that the truth stands up is to have hard evidence from the aircraft accident. And so we took the airplane completely, and we put it in our lab in Ottawa.
Anything?
With signs pointing to engine failure as the cause of the crash,
strip it down.
Roa orders extensive engine testing.
Those engines were examined in detail for damage.
Roa finds the F-28's 2 Rolls-Royce engines suffered only minor structural damage. There's no evidence of an engine fire, nothing at all to suggest the engines had failed. With little physical evidence to explain the failed takeoff, investigators are back to square one. To solve the mystery, they comb through survivor and eyewitness statements. A common thread emerges.
They said in their witness statements there was snow and ice on the wings when the airplane attempted to take off.
Roa studies weather charts for clues.
We had very good meteorological information.
The charts show that during the half hour the F-28 was on the ground at Dryden Airport, visibility shrank from 4 kilometers to less than 1 kilometer because of the snowstorm.
And though we may find other reasons, for sure snow and ice on the wings was a factor in this accident.
Sonia Hartwig tells investigators about an unusual sight during takeoff.
As we took off, I noticed that the wings just became a solid sheen of gray, shiny ice.
Investigators consult the F-28's manuals to study its anti-icing systems. They find that only the wing's leading edges are protected.
The aircraft had heated leading edges on the wings.
I wonder if the anti-icing system was working.
And the heat was provided by bleed air from the compressors on the engine. They found the valves that allow the compressed air access to the leading edges. And they tested the valve to see if it functioned, and it did.
The anti-icing system was working. But since it only heats the leading edge, it likely didn't clear ice that formed on the surface of Flight 1363's wings. Investigators suspect that snow and ice buildup, what experts call wing contamination, may have played a major role in the crash. To verify that suspicion, Roa and his team meet with engineers from Fokker.
Thanks for coming. Curious to see what you have.
Jack Van Hengst, who was the chief engineer, had extensive aerodynamic studies and data on the effects of contamination on an F-28 airplane.
Fokker engineers have run simulations of the crash.
They were able to get some very good data in terms of the performance of the airplane, simulating the type of loads, temperatures, etc., that the Dryden aircraft would have been exposed to.
Investigators make a crucial discovery about the design of the F-28. Because of the angle of the wings, a very small amount of ice makes the plane susceptible to stalling.
They concluded that even the most minute bit of contamination on the wing would disrupt the airflow and cause a loss of lift.
Well, that answers a lot of questions.
The simulations support what witnesses saw.
It just barely got airborne, dropping wings, losing lift, and then hitting trees, decelerating to the point where it broke up.
Investigators are now certain that contaminated wings caused the crash. But what's still unclear is why the plane was not de-iced before takeoff. Almost all airports in cold climates, including Dryden, are equipped with the technology to remove ice from a plane. But Captain Morwood never requested de-icing.
It's getting worse. What's the latest?
And it won't clear until late afternoon.
Investigators need to figure out why. They want to understand what made him risk his own life.
Let's hope it holds.
And the lives of the 68 other people on board Flight 1363. Investigators dig through Captain George Morwood's flight records and work history. They interview crew members, searching for clues to his behavior.
Captain Morwood was a very professional, very old-school pilot. He had his view on how things should be done properly and what his definition of proper and professional would be.
He also was very concerned about his passengers. He enjoyed making sure that they got on their flights on time and got to their destinations on time.
You know, Air Ontario was a growing company. It was their first foray into jet operations. I'm sure that there were many things that Captain Morwood would have thought in his own mind, this is not how he would do it. And I'm sure at times he probably let the superiors know that.
Morwood's history shows he's delayed and cancelled flights in the past because of icing concerns. Roa is stumped. Why didn't he request de-icing in Dryden? Another pilot who was at Dryden Airport that day provides part of the answer. He heard Morwood on the phone to Air Ontario.
That is what I have been trying to tell you.
He was very frustrated, and he was really concerned about his passengers.
Morwood complained to the off-duty pilot about the company.
These guys. You want to guess my weight before I left Thunder Bay? 66 and change. I had to offload fuel. Now that... Right. So now what am I supposed to do? No. You figure it out.
When he left the terminal, he was observed by witnesses to appear to be very upset and very angry.
Investigators wonder what set Morwood off. They try to piece together the pilot's day on March the 10th.
This was the 5th day of a very long week for Captain Morwood. And he was the next day leaving with his family on a ski vacation.
Before his first flight of the day, he'd learned the plane's APU still wasn't working. And then, once in Thunder Bay, more bad news. After refueling, the dispatcher forces Morwood to take on 10 extra passengers. Now he must offload fuel and lose more time.
There goes the schedule. Let's, offload some fuel then.
This meant Morwood would leave Thunder Bay behind schedule.
Dispatch, Ontario 363.
And Captain Morwood is the type of captain who didn't want to be late.
Now en route to Dryden, and an hour behind schedule, the weather forecast the crew was given of light rain and fog is no longer accurate.
And Captain Morwood didn't get the forecast of freezing rain coming into Dryden, which he should have had.
As Flight 1363 lands in Dryden, the weather was getting worse by the minute. The plane sat there for half an hour while snow built up on the wings.
I gotta talk to somebody about this.
Investigators may never know how concerned Morwood was about the weather. But there is evidence that it was on his mind. When Roa questions the fueling agent, he learns that Morwood did ask about de-icing moments before takeoff.
Is there de-icing available?
The fueling agent says he pointed out the de-icing ground crew to Morwood. The agent then offers a compelling reason that could explain why the captain didn't de-ice. Air Ontario had a policy prohibiting him from de-icing with an engine running.
The fluid can be ingested in the engines and then find its way from there to the air conditioning on the airplane and make it extremely noxious in the cabin portion of the airplane.
But if Morwood had shut down both engines, he wouldn't have been able to restart his plane.
Now, the only other way to start the airplane on the ground is with a ground-based air cart that can provide the compressed air. And Dryden did not have the capability to start the airplane.
The equipment would have had to be flown in from Winnipeg. It would have been a costly decision.
If he shut it down, he would ground the aircraft there effectively, requiring the billeting of passengers and hotels and at an expense to the airline for which he would be answerable.
Right. So now what?
So he was under a great deal of pressure.
No. You figure it out.
And I believe that the conversation on the phone would have been about that scenario and his displeasure with it. But he didn't have any other chance.
It's getting worse. What's the latest?
Quite heavy snow. Looks like it's going to be a bad one. It's still within our takeoff limits.
Well, that's good. We got a lot of people who want to make the connectors. Let's hope it holds.
Though the amount of snow on the wings was still within limits, it's what lay under the snow that doomed the flight. The fuel in a plane's wing can get as cold as minus 40 degrees Celsius. The frigid fuel cools the metal surface of the wing. When snow hits this supercooled surface, it freezes instantly into a barely visible layer of ice. It's a process called cold soaking.
And this, of course, is what's disrupting the airflow on the wing and destroying the lifting capabilities.
Tell them we're going immediately.
Kenora, Ontario, we're taxiing out at this time, 360.
The only reason that I can possibly think of that led to his decision to execute the takeoff was the fact that he didn't consider the cold soaking phenomena and the fact that those wings could still have ice on them.
Advise Kenora, we're ready to proceed.
And Kenora Dryden, Ontario.
Perhaps not wanting to face the consequences of shutting down his engines, Morwood opted to take off for Winnipeg without de-icing his plane.
He must have concluded that the ice would blow off on takeoff. That is where he made a mistake, a tragic mistake.
But Mashansky concludes that despite his mistake, Captain Morwood is not solely responsible for the crash.
It wasn't simply pilot error. There were myriad of factors which were the cause of the accident.
One of the most important factors, Air Ontario's decision to let the plane fly with a broken APU.
They were deferring a lot of the maintenance that should have been done because of a shortage of parts. And then they had to scrounge around all across Canada with various F-28 operators to borrow parts from them. And this was a very bad move on the part of Air Ontario management.
The investigation determines that by cutting corners and focusing too much on the bottom line, the airline was putting all their passengers and employees at risk.
Because the F-28s were new to Air Ontario, there was this urgency to get one crew off and get the next crew on flying. This urgency to have them in the air producing money.
I came to the conclusion after a lot of thought about this accident that there were a lot of other hands on those throttles, pushing those throttles forward. There were a lot of people that were involved in the sequence of events that led to this tragic outcome.
This was a preventable accident, but everything conspired against the pilots.
I gotta talk to somebody about this.
Because Air Ontario management did not have a safety culture. And you have to have a safety culture from the top management down.
Knowing there are dozens of Fokker F-28s flying around the world, Justice Mashansky takes an unusual step. He releases a report well before his inquiry concludes.
Good afternoon.
It warns of the plane's vulnerability to ice buildup and stresses the need for frequent de-icing in winter conditions.
Even a small amount of icing would be disastrous on an F-28.
But 15 months later, it becomes clear that Mashansky's warnings have not been heard. US Air Flight 405 is preparing to fly from New York to Cleveland on March the 22nd, 1992. The plane is a Fokker F-28, and it's snowing. It's 1 degree below freezing. At 9 p.m., the jet is being de-iced for a second time since its arrival from Florida. In the past hour, an inch of snow has fallen and shows no signs of stopping.
US Air 405, clear to taxi runway 13.
The crew prepares for takeoff. Flight 405 is an hour and 45 minutes behind schedule when Captain Wallace Majeur starts taxiing to runway 13. Then, unexpectedly,
US Air 405, turn left and hold short of Echo.
Left on the inner to hold short of Echo.
At 9:07 p.m., Flight 405 is forced to wait on the taxiway near runway 13. Another 23 minutes pass. First Officer John Rashuba turns on a light that illuminates his wings. He checks the right wing for ice. He sees none.
Looks pretty good to me as far as I can see.
US Air 405, runway 13, clear for takeoff.
Even though it's now been 35 minutes since their last de-icing, the crew does not request another.
Takeoff thrusts set. Temp's okay.
Everything proceeds as it should. Until...
V1. Rotate.
Just after the F-28 begins its rotation.
The aircraft had enough flying speed to lift off. Barely lift off. The wings just could not support the airplane. They knew they were in trouble.
13 seconds after lifting off, Flight 405 crashes on the shore of Flushing Bay.
I don't think any pilot really thinks he's going to crash. They were trying to save the airplane right to the end.
27 of the 51 people on board are killed. Another Fokker F-28 has crashed, with tragic consequences.
My reaction when I heard about it was, my God, it's Dryden all over again.
Within days, investigator in charge Robert Benson suspects that ice on the wings was the major cause.
It would be very, very difficult for either of the pilots to really detect ice on the wings, looking backwards over their shoulders through the side windows of the airplane.
Looks pretty good to me as far as I can see.
So the captain was faced with quite a problem. If he wanted to be de-iced a third time, he would have had to get out on the lines, taxi all the way back into the parking area, and meet up with a de-icing truck again.
Takeoff thrusts.
That would have put him very, very late, and it may have even caused the cancellation of the flight.
After all of this work, after all of the efforts, to see it happen again was extremely frustrating.
There were no regulations in place requiring the crew to seek another de-icing after their extended delay. But Justice Mashansky had called attention to the dangers of long wait times when he issued his interim report.
If they had followed the recommendations in my second interim report, this accident certainly could have been averted.
He also had drawn attention to the limitations of the de-icing fluid being used at the time. Called Type 1 fluid, it's a mixture of antifreeze and water.
Those chemicals are designed that as you accelerate down the runway, that they'll actually shed off your wing, so that when you actually want the wing to lift and produce lift, that it's not contaminated.
Type 1 fluid is applied hot to de-ice the plane's surfaces. But it doesn't last long.
Type 1 fluid had a holdover time in their best conditions of about 15 minutes. Under poor conditions, such as freezing rain, it could be as low as 6 minutes.
During the Air Ontario investigation, Mashansky's team reached a stark conclusion about the effectiveness of Type 1 fluid. Even if Captain Morwood could have de-iced his plane in Dryden,
We're fired up, taxiing for departure, requesting airways to Winnipeg.
it may have made no difference.
Hang on a sec, guys. Is there a chance that plane can hold? We're having some bad weather up here.
Unbelievable.
Flight 1363 had to wait for the troubled Cessna 150 to land.
By the time he waited for this 150 aircraft and pilot to land, and then they backtracked and got into position, now they're in a serious snowstorm, and they are getting contaminated.
Even if Morwood had de-iced during his 30 minutes on the ground,
rotate.
The delay may have been enough for the fluid to stop working. The plane's wings may once again have become coated in ice.
It came out in the examination of Air Ontario pilots that there was a dire need for training in terms of how the de-icing, anti-icing systems worked and how long your aircraft was protected.
As soon as our accident occurred up in New York, we of course understood that it was a similar aircraft, in fact a nearly identical aircraft to the Dryden accident airplane. The circumstances were similar in both accidents, and the Dryden report was a tour de force, which helped us focus our investigation quite a bit.
Justice Mashansky had released his interim report more than a year before the crash of Flight 405. His recommendations could have prevented it. Mashansky would soon discover that a breakdown in communication had cost the lives of 27 people in New York. During his inquiry, Justice Mashansky learned that there was another type of de-icing fluid available to the airline industry. It's called Type 2 fluid. It's thicker than Type 1, which prevents it from immediately flowing off an aircraft.
A Type 2 fluid is a much more gooey substance. I've heard it referred to as almost mucus-like.
With holdover times of up to 45 minutes, it keeps ice from accumulating, then blows off the plane's surfaces at takeoff. 15 months before the US air crash, Mashansky recommended greater use of the thicker Type 2 fluid. Mashansky's investigators also studied de-icing practices at Toronto's Pearson Airport.
We got hold of a film crew, and we waited and watched the weather very carefully until we found a forecast of freezing rain. And we tracked one aircraft which was heading for the Caribbean.
The investigators discovered an alarming gap in the time between de-icing and takeoff.
And from the time the aircraft was de-icing on the gate until the time the aircraft took off was somewhere in the order of 41 minutes. So there was no doubt that aircraft were departing Pearson Airport with a partially or largely contaminated wing surface. We then went to Chicago O'Hare. This was the first airport to actually put in place runway end de-icing pads. And it was very useful in terms of explaining to us how these had evolved, what type of de-icing equipment they were using on them, how they worked.
At the time of the US air crash, LaGuardia did not offer de-icing at the runway, only at the gate. Again, 15 months before the crash, Justice Mashansky recommended the placement of de-icing facilities at runways instead of terminal gates. Mashansky also recommended that pilots not only inspect their wings from the cockpit,
Looks pretty good to me as far as I can see,
but also from the cabin.
US Air 405, runway 13, clear for takeoff.
Mashansky claims that his report could have prevented the crash at LaGuardia. But the Federal Aviation Administration claims it never received his report in 1990, and therefore couldn't pass the information along to airlines and pilots. But Justice Mashansky doesn't accept that.
My second interim report went out in December of 1990. It's about a year and a half before the LaGuardia crash occurred. So I think probably sat on somebody's desk.
The crash of Flight 1363 resulted in dozens of recommendations that could save lives. The crash of Flight 405 ensured those recommendations were widely implemented.
Well, there was a lot that came out of Dryden. I mean, the Commission came out with 192 recommendations. It changed the whole nature of how we approach contamination.
We now have runway end de-icing pads, so they can get a final de-icing before they take off. This was something directly the result of the Dryden Commission inquiry.
Today, most airlines use a new type of de-icing fluid. Type 4 de-icing fluid lasts longer. It will stick to a wing for up to 2 hours. As well, air traffic controllers must now be able to tell flight crews how long they will be delayed at the runway after being de-iced.
Dryden is really the first accident that explored not only what happens in the pointed end of an airplane, but what happens within a corporate culture. It put CEOs on notice that they can't hide in the woodwork when an accident occurs.
Dutch manufacturer Fokker went bankrupt in 1996. Despite this, in 2009 there were still 55 Fokker F-28 jets in operation worldwide, mostly in warmer climates.
Nobody should ever lose their life due to a contamination accident again in commercial aviation, anywhere in a snow and ice environment. We've learned all the lessons.
Fast.
You have 811 Heavy? Do you have the airport in sight?
It's over here to the right, Captain. Okay.
Okay, we have the airport. United 811 Heavy.
811 is clear to land 8 left. Equipment standing by. Wind 05012.
Clear to land. 8 left, United 811 Heavy.
As the unstable 747 lined up for landing, the pilots knew they would only have one chance. But even if they got it on the runway, the nagging question remained. Would the stress of impact cause the damaged and overweight aircraft to disintegrate? Severely damaged, with an unstable airframe and losing altitude on just 2 engines, Flight 811 now began its final approach to Honolulu Airport.
2-engine approach.
2-engine approach.
We still had no idea how far off the ground we were, if we were going to make it to Honolulu or not. But that seemed like an appropriate time. If we were somewhere around land, that we're probably going to try and land somewhere to get the passengers in their brace positions. So that's when we started yelling for them to get down in their brace positions.
Every molecule in my body combined to express, get this damn airplane on the ground.
Well, how are we doing on the hydraulics?
Hydraulics are good.
You got brakes?
Normal hydraulics.
So we got brakes, but you're only going to have reversing on 1 and 2.
Though I thought maybe there was a chance that we were going to actually be able to attempt to land, the thought came to my mind, what happens now? Do we, on impact, do we explode? Do we fall out this huge hole?
Despite dumping fuel, the aircraft was still critically overweight, but without full flaps to keep it in the air. It had to approach fast.
1,000 down.
The danger was that the undercarriage could shear off and the plane break up.
Top and a half high. 190. 185. A little slow, Dave. It's below what we want.
Let's try the gear.
No one knew if the explosion had damaged the landing gear.
I remember Laura saying to me that she didn't hear the landing gear go down. And it was loud, it was still loud, and I didn't hear the landing gear go down. So that's another thought. Maybe they can't get the landing gear down. Maybe it's not down.
We've got the gear down, we're clear to land, and everything's taken care of as far as we know. $200. 195. Half a dot high. Looking good. 192. 195.
Coming off on the power. 100 feet. $50 feet. Center the trim. Center the trim. 30. 10. 0.
We're on.
Gear's holding.
We landed. It felt fast. And that was my next concern, is that we weren't going to stop at the end of the runway, that we were just going to keep going.
And all of a sudden, we were slowing down, and I said, "Oh my God, we've landed. We're on ground." And the people started applauding.
Probably the best landing I've ever made. When we finally stopped on the runway, we deployed all 10 chutes, and the flight attendants evacuated all the passengers.
It's amazing how fast everyone went. My understanding is like less than 45 seconds, 330 people were off the airplane.
We were probably 20 feet off the ground, and I would have stepped out of the airplane without a slide. I wanted to get off so bad.
When we got all our switches off, I ran through the airplane, made sure there was no one else on the airplane, came up to the door one left, and went down the slide, and I came around the front, and I saw that humongous hole in the side, and I just couldn't believe it. By the grace of God, we made it, and it was an awesome experience. I would never want to go through that again.
It was crazy, it was wild, it was scary, all at the same time. I just thought that that was the end, that we were going to die. I mean, that was my first thought, that this is the end.
But for the families of the 9 people who were killed, the ordeal was just beginning. Kevin and Susan Campbell's son, Lee, had been flying home.
About 3 o'clock in the afternoon, I think they said that there was no New Zealanders involved, but we just knew that it was Lee. And then about, I suppose, a quarter of an hour later, we got a phone call from Chicago, and they just said that they regret to inform us that our son was missing, presumed dead. And I guess about another hour after that, a policeman arrived at the door, and he took one look at us and he says, "I can see that you've had the news." So it was just an awful day. And it certainly didn't get much better for a long time.
Although Lee's body had not been recovered, the Campbells flew straight to the wrecked aircraft in Honolulu.
Your initial feeling is that you want to be as close to the spot where your relative died, and that was the aircraft. So we had to immediately go in and see the aircraft.
The damage inside was horrific, just a total mess. And the hole in the side of the aircraft was much bigger than I had thought it would be, even though we had seen television newsreel reports. And it was so sad to get in and actually see where Lee's seat had been. The legs of the seat were still there. There was a good bit of fuselage beside him and still a window.
But the Campbells' desire to find the cause of Lee's death inevitably brought them face to face with the dreadful details.
They took us to the medical examiner's office as well, because they had found body parts and that sort of thing. So they didn't actually show us the body parts, but they showed us bits and pieces that they had recovered from the engines, and we got the medical examiner's report on what they had recovered. So, you know, we really would have preferred that it was Lee that went through the engine, because it would have been an immediate death, whereas it was a 4-minute fall down to the ocean, and we know that the people could have been alive as they were falling. And when you think about that, that's just horrific.
As it became clear that their son's body would never be found, the Campbells' need to find the cause of the accident that killed him grew stronger.
Lee can't have died for nothing. You know, you've got to find out why he died, and you've just got to make sure that it never happens again.
The Campbells embarked on a relentless personal investigation that would last nearly 2 years. But the loss of their son meant they would stop at nothing to uncover the truth.
The engines number 3 and 4.
2 months after the accident on Flight 811, when the National Transportation Safety Board held preliminary hearings, the Campbells made sure they were there. But they soon grew frustrated. The NTSB would not complete its report for months, so the Campbells took matters into their own hands.
This accident was the sudden opening.
We certainly weren't going to leave it to the NTSB to come up with the findings. We were going to follow through. And when the hearings ended, they had said that we could take whatever we wanted off the press table. And Susan walked up to the top table and yelled out, "There's a really good setup here." So grabbed a box and loaded in all of the documents that we could find up there.
Kevin's the most honest of people I know, but here he was taking something that we hadn't specifically been told we could take.
And we're heading out the door just as the NTSB were arriving back in with the trolley to pick up all their documents. So we were out the door and into a taxi and gone.
So we quickly realised we'd got a really good set of papers with a lot of things that hadn't been released to the public. We were able to really start our investigation in earnest at that stage.
The unpublished documents revealed a disturbing catalogue of problems with the forward cargo door, going right back to its original design. Instead of a plug door that gets jammed into its frame as the aircraft pressurizes, Boeing opted for an outward opening door. This allowed for more cargo space, but was not fail-safe like the plug design. So Boeing built what they believed was a foolproof locking mechanism.
What they do is they build in multiple redundancies to make sure the door is properly latched and does not open. And you build it in to a point of that it's extremely improbable that the door would ever open.
So what went wrong on Flight 811? The Campbells soon discovered the problem lay in the design of the locking mechanism. To lock the cargo door on the 747, electric motors rotate C-shaped latches around pins in the door frame. A handle then moves L-shaped arms, known as locking sectors, over the top of the C latches to prevent them from opening. But as early as 1975, problems were found with the locking sectors. Kevin Campbell, an experienced engineer, built a model to show the weakness in the Boeing design.
Initially, the locking sectors were made in aluminium, and in 1975, Boeing realised that they weren't strong enough, and they actually doubled up the aluminium to make it double thickness. But it still wasn't strong enough, and a lot of the airlines didn't even put the doublers on anyway.
The weakness of the aluminum drastically increased the risk of the door accidentally opening.
With the aluminium locking sectors, if the C-locks tried to backwind, open electrically, it would just push the locking sector out of the way. It just simply wasn't up to the job that it was designed for.
For 20 years before the catastrophe on Flight 811, 747s had been flying with this crucial weakness. The Campbells wondered what else remained to be revealed. They redoubled their efforts to uncover the full truth behind the accident that had killed their son.
We bought a car and set off in the United States to see as many people who were involved with the accident as possible. We started at Seattle, crossed to Chicago, through to Washington, D.C., down to Kentucky, on to Miami, and back across to San Diego, back up to Seattle. And that was just one trip.
The Campbells soon found that a shockingly similar incident to Flight 811 had given clear warnings of the danger in the cargo door. In 1987, 2 years before Flight 811, a Pan Am 747 had been climbing out of Heathrow when it failed to pressurize at 20,000 feet. The pilots had to turn back.
When they got back to Heathrow, they found that the door was hanging open 1.5 inches at the bottom, and all of the locks were open. When it got to the maintenance base, they found that all of the locking sectors were either bent or broken.
Why had the sea latches turned and bent back the locking sectors? Boeing claimed that ground crew must have mishandled the mechanism. But the Campbells' investigation uncovered another vital clue to why the sea latches had turned. A report highlighted problems with the door's electrical system.
It had a fault in the S2 master latch lock switch that should have turned off the power to the door when the outer handle was closed.
This was an alarming finding. When the outer handle was closed, the S2 master lock switch was meant to disconnect the power supply and stop the C-latch motors from turning. So could this have failed, allowing the motors to open the door? To find out, Boeing asked the airlines to do a simple test: close the outer handle, then press the switch to open the door, and see what happens.
When they hit the switch, it actually worked. Boeing thought, this is not going to work, but it actually worked. There was power to the door locks with the outer handle closed, and the lock started to move, and it started to force the locking sectors out of the way. And a few days later, the airline started ringing in and saying it was damaging their planes. So Boeing stopped the test. But it meant that on those aircraft, the S2 switch had failed, which is a silent failure. And all of those aircraft were likely to have the same problem as 811. They were just waiting for a short circuit to open the doors.
The Campbells now became convinced that the accident on Flight 811 began with the failure of the S2 switch. Power remained onto the C-latch motors. All it took was a short circuit in the 20-year-old wiring, which had been found to be frayed on other aircraft, to start the motors up. The aluminum locking sectors were too weak to stop the latches turning, and the cargo door burst open.
The National Transportation Safety Board determines that
After a year of investigation, the NTSB had a different version of the events. The Campbells were in for a shock. After waiting a year for the official report, Kevin and Susan Campbell expected it to match their theory of what led to the accident on Flight 811.
I assumed that we would have a report come out that this was an electrical malfunction, and was staggered when they came out and said that the door had been mishandled.
For the Campbells, the NTSB's flawed explanation and failure to mention the electrical problems just wasn't good enough. They went back to investigating the accident on Flight 811 and soon found disturbing evidence of how it could and should have been prevented. After the Pan Am incident in 1987, it turned out that Boeing had issued a directive to the airlines on how to correct the weak aluminum locking sectors.
The airworthiness directive that came out was to replace the aluminum sectors with steel sectors that could not be bent. And there were some some interim requirements for inspections to be performed until what they call terminating action, the steel sectors were installed.
The fix was cheap and simple, but getting it done was not.
The actual cost of the modification, changing these locking sectors to steel, was $2,000 per aircraft, but it took 10 hours to do it, and that's where the money was. Taking the aircraft out of service for 10 hours, that's millions of dollars.
The Campbells discovered that back in 1988, the FAA, whose role it is to enforce improvements, had given the airlines 18 months to comply. Within a year, Lee Campbell and 8 others would die in an avoidable accident. So why weren't the airlines forced to fix the problem sooner?
If these airplanes, these large commercial airplanes, are grounded, it's an economic disaster. So what they do is they lobby in the regulatory agency in the United States, it's the FAA, to allow them to do the fixes over time when the airplanes are in for normal maintenance. And that way, they're not taken out of service. But when they do that, when they allow the airlines, the air carriers, and the manufacturers to fix these over time, in essence what the FAA is doing is they're gambling with the lives of the passengers and the crew that are flying the airplanes during the time they're not fixed.
After the deaths on Flight 811, the FAA instantly shortened the deadline for fixing the cargo door from 18 months to just 30 days. The pressure of the Campbells' campaign eventually began to pay off. The vital piece of evidence that could prove them right, the cargo door, still lay 2 miles down in the Pacific Ocean. But as articles appeared in the American press, the NTSB commissioned the U.S. Navy to search for it. 100 miles south of Honolulu, a deep submersible began to trawl the seabed.
We went to Honolulu and waited there while they had their attempts. And they finally recovered the door from 14,000 feet of water, which was the deepest recovery ever at that time. And we were phoned within an hour of it coming out of the water.
But before the Campbells could see it, the door was swiftly removed to Boeing's plant in Seattle. The Campbells went in hot pursuit.
We went over to Boeing, and they wouldn't show it to us. So they reckon that the crucial pieces had gone to the NTSB. So again, we got in the car and drove across to Washington, D.C. We arrived at Ron Schleid's office, and Ron looks at his watch and he says, "I can give you 5 minutes." So about 3 hours later, we had the pieces that they recovered in our hand, and they acknowledged that we're definitely correct. It was an electrical malfunction.
Finally, the NTSB publicly issued a revised report that concurred with the Campbells' version.
There was an inadvertent failure of either the switch or the wiring that caused an uncommanded opening of the door.
It's nice that other people know that you're right and had been all along, and the support that they had given you was vindicated.
The Campbells spent thousands of dollars of their own money on their campaign. They were never interested in a financial settlement for Lee's death, but they did persuade United and Boeing to set up a university scholarship in his name.
I couldn't have lived with myself if we had done no investigating ourselves. It was just something we both felt we needed to do. We didn't even discuss it. We just knew that's what we would do.
Yep.
But despite long and public campaigns like that of the Campbells, critics fear that the airline industry has not learned the lessons from Flight 811.
The regulatory agencies, they have a dual charge. One is to encourage aviation, and another is aviation safety. And when they get in a position where you have economics up against air safety, they tend to err on the side of economics rather than safety.
Serious accidents caused by known defects have continued to occur. In the 1990s, known problems in aircraft de-icing systems led to crashes. At least 3 planes have had fatal fires due to known dangers from flammable insulation material. In 1998, a fully laden 747 blew itself up over the Atlantic when known faults in the old wiring ignited known hazards in the fuel tanks. Inevitably, experts are skeptical about the industry's record of balancing profit against prevention.
And what the industry says, you know, to go in and replace this wiring would ground all these airplanes, would be astronomically expensive. You know, one airplane every 10 years, one airplane every 5 years, 200-300 people, cost of doing business. Cost of doing business. And that's a great economic analysis, and unless your mother or your child is on board one of these airplanes that happens to pay the price for their economic satisfaction.
For some of the survivors of Flight 811, the cost has been heavy.
Each crew member handled it differently. I know there are still 2 crew members that have never set foot on an aircraft again. It was very difficult for me. I was diagnosed with severe post-traumatic stress disorder. You can't reason, you can't think. Making the slightest decision is very difficult. You're just at a total loss. So it was very difficult to cope with.